Hello guys, day 8. This one was actually quite a bit harder than the rest. Yeah, it got me thinking for a bit. I tried to brute force it, and the program was running for 3 days. 3 hours, and I eventually had to change it up. So let's get into it. So pretty much this is a graph traversal problem. You start at A, you have to get to Z, and you just keep following these instructions. So here you go right, left, right, left, right, left, because these are RL. Whereas here you go left, left, right, left, left, right, left, left, right. So you start at A, you go B, you're at B now, you go left again, you go back to A, you go right because you've gone left, left, right, blah, blah, blah. Pretty simple. Let's look at the question. So the first thing I did was I got the instructions and then I got the mappings. With this mappings, I pretty much made a map so that every, let's take this one for example. Here, A would be mapped to a pair of B and C, where the first value is B, BB, and the second value is CCC. And then yeah, we pretty much I ran a DFS, so we just keep using this tailrec function. If we're not at ZZZ, we're just going to keep going. We get the current instruction. If it's right, we go to the right value. If it's left, we go to the left value, and we add 1 to the score. And then yeah, we just return the score when we get to the end. Part 2. Now pretty much we have to go from all the values starting with A to all the values starting with Z at the same time. So what happened here was that I tried, just brute forcing and leaving it running, but it was taking way too long. So got a little help from my friend suggested, like, hey, what about lowest common multiple? So here's a little graph that you can think about. When the distance from, say A to the first Z value, this is A1 to Z1, that could be some value, say it's like 50. We need this, we either need this value to align when all the others, when A2 aligns with Z2, and when A3 aligns with Z3, and so on, all the way to whatever, however many we have. In my case, I had 5. However, since I left this running for 3 hours, I knew that it was very unlikely for it to happen between this range of A1 to Z1. So what actually is needed is that you need A1 to get to Z1 first, and then, sorry, it's kind of see that. You need A1 to get to Z1, and then you need to actually loop back to Z1. And then you want this to keep looping. A1's going to keep Z1 to Z1 is going to keep looping. Z2 to Z2 is going to keep looping, and so on and so forth. And eventually, these are all going to line up on the exact same one. So if you find out the value of the length of each of these loops, say this is L1 and this is L2, then the lowest common multiple of L1 to Ln will be the first point at which they all converge on Z. Because you can imagine each of them are going in a circle, and they're meeting up at some stage. They're going to meet up at the same point. I heard this is kind of like a lunar orbits analogy where there's a bunch of planets that are all like this, and they're all going in their own circles, and then eventually they all meet up at like one point. Or in my case, they don't, but let's say they all meet up at this one point, and that's the lowest common multiple of all of them. So let's look at the code. Pretty much same thing. I get the mappings for each of them, and then I get the points that end with A. So this is all my starting points, so all the ones ending with A. And then what I do is I find it's probably poorly named because it's not really lowest common multiples, but I find the first Z value of each A value. Then I find the second Z value, so that's when it loops around the first time. So now I have the length of the loops of each of them. So for every Z value, I know how long it takes to loop back to itself. And then I just get the lowest common multiple of these, which is some function I copied from the internet. That's all. Thanks for watching.